Alright guys, welcome back. Let's see if we can solve another question from the second chapter of the Engineering Mechanics by Miriam, and we have question 88. An exhaust system for a pickup truck is shown in the figure. The weights of WH, WM, and WT of the head pipes, muffler, and the tailpipe are 10. So let's just write it down in here. So WH is 10 newtons, WM is 100, and WT is 50 newtons respectively, and act at the indicated points. If the exhaust pipe hanger at point A is adjusted so that its tension is 50 newtons, so we know FA is 50 newtons, we need to determine the required forces in the hangers at point B, C, and D. So we have three unknowns. I'm just going to highlight it in yellow, these three, so that the force couple system at O is 0. All right, so for finding the force couple system, at the end of this, we need one single force that represents all the forces that we have in this system, which let's just call it our resultant, or R. So sum of all forces has to be 0 because the question is asking for a 0 force coupled system, and also a moment about O has to be 0. So we're going to get two equations from the first one. Sum of all forces in x and y equals 0, and we have one moment equation. We should be able to find the three unknowns that we have in this question. Also, at the end of the question, we have that why is the zero force couple system at O desirable? And the reason is that if there is a net force at point O, it would transmit vibration into the frame. It can cause noise inside the vehicle. It can create fatigue stresses in the bracket and eventually lead to cracking or failure. So it makes sense for us to not have any moment or force at point O in order to have the pipe balanced. All right, so now that we answered the last question, let's just go for finding the FB, FC, and FD. Let's start with the sum of all forces in x equals 0. Let's just show our x and y axes in here. So looking at the Fx, we have two forces that are in x direction, FD and FC, and they are making the same angle with the vertical, 30 degrees. So, and these are the only forces that we have in x direction. So basically we have FD cosine of, sine of 30 degrees for FD, which is positive, and negative FC sine of 30 degrees equals 0, which basically means FC is equal to FD. That's our first equation. Let's move on to sum of all forces in y equals 0, and we can see we have FB upward, we have 50 newtons, which is FA. We have all the weight, negative 10, negative 100, negative 50. And on top of this, we have the y component of FD and FC. So because they are the same force, I'm just going to go with FCD. They're both upward, so just going to go with FC and the cosine of 30, and we have 2 because there is 2. FC cosine of 30 degrees equals 0. And now we have one equation based on FB and FC, which means we need to move on to our last equation. So let's move on to our moment about point O, and let's see what we get for that, and we're going to come back to this equation later. So sum of all moments about O has to be 0 in order to get that 0 couple at point O. So we have the moment of the WH is clockwise, so negative 10 times 0.5, and negative because it's clockwise. We have moment of FA, that one's counterclockwise, positive, so 50 times the distance is 0.5 plus 0.2, so 0.7. We have the moment of WM, again clockwise, so negative 100 times the distance is going to be 0.65 plus 0.7, so 1.35. We have the moment of FB, which we can see it's counterclockwise, so positive. FB times the distance would be 65 plus 65, so 1.3 plus 7, so that's going to be 2. FB is out, and we can see FC and FD. We can resolve them into two components, but before that, let's just do the WT2. So WT is also clockwise, so negative 50 times the distance. Let's see what we get. So we had 2 for this part plus 0.5, so 2.5. And if we go with the x and y component of each, we can see that the x component of these two forces, FC and FD, won't make any moment. because it passes through the point O. So no moment from the x components, but the y components, which are f sine of, f cosine of 30 degrees, they're going to make moment. And I'm just going to call these 2f cosine of 30 degrees, which is the resultant of the y component of FD and FC and FDF. So 2f cosine of 30 plus, and the moment we can see that it's gonna be counterclockwise, so positive plus 2, we call it FC cosine of 30 degrees, and that's the force, and the distance would be, again, we had 2 plus, this is going to be 0.9, so it's going to be 2.9. Let's just show it in here. 2fc times cosine of 30 degrees times 2.9. All right, so we have another equation based on FB and FC, and the previous one we had another equation based on FB and FC. So what we're going to do is that in the previous one, we're just going to find the FB based on FC. I'm just going to plug it in the second one, and we should be able to find the, so FB in here would be, we can cancel these, and if we just bring it on the other side, would be 110 minus 2 FC cosine of 30 degrees. So let's just double check everything. 110. Yeah, so everything's correct. Let me just clean up this one a little bit. -5 is going to be 35, -135. And this is going to be -125. All right, so we have 2FB. I'm just plugging this one in the second equation. So 2FB would be 2 times 110 -2 FC cosine of 30 degrees. And we have -5 plus 35, -135, -125. So that's going to be -230 plus 2FC cosine of 30 times 2.9, and this will be equal to 0. So that's going to be 220, and from these two we can factor to -2FC cosine of 30 degrees. So the first one is going to give us 2, and the second one is going to give us plus -2.9, and -230 equals 0. So 2 FC cosine of 30 degrees times -1 or -0.9 minus 10, plus 10 is equal to 0. So this is gonna give us FC, which is 10 over 0.9 cosine of 30 times 2. And yeah, that's gonna give us FC 6.42 newtons, and we've figured out that FC is equal to FD. So now that we have these two, we should be able to find the FB from here. So FB is basically 110 minus 2 times FD, which was 6.42, 42 times cosine of 30 degrees. And yeah, that's gonna give our FB 98.9 newtons, and the final answer for this question. So it's just a matter of calculation after writing the equations, but other than that, it's pretty straightforward. And why is the zero force coupled system? 0 is desirable at O, and the reason is because that by making the resultant force and moment at O equals 0, the hangers carry all the loads, so the pipe remains balanced, and this keeps the connection at O unstressed and prevents vibration and noise from being transmitted to the truck body. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.